In this video, we want to solve this differential equation given these two initial conditions. So note that this is the function of x. So we'll treat this as x of t, where x is our dependent variable and t is our independent variable. So in order to solve this, we're going to let x equal e to lambda t. So replace e to lambda t in for every x we see. So we'll take this second derivative, will be lambda squared times e to lambda t. The first derivative is just lambda e to lambda t. And then from here, we want to solve for lambda. Notice that we have e to lambda t's in all three terms. So pull that out. What's left is 4 lambda squared plus 20 lambda plus 169. And here, e to lambda t is always going to be positive. So I did skip a couple steps. I set 4 lambda squared plus 20 lambda plus 169 equal to 0. And for this, I had to use a quadratic formula, which is opposite of b plus or minus b squared minus 4ac all over 2a. And so that simplifies to negative 5 over 2 plus or minus 6i. So for lambda equals negative 5 over 2 plus 6i, our solution is going to be c1 times e to that lambda t, because recall we said x is equal to e to the negative lambda t, or sorry, e to the positive lambda t. So we're just replacing lambda with what we found. Similarly, for negative 5 over 2 minus 6i, we do the same thing. And now we just combine them to form x of t. Okay, now we want to use the initial condition. So given our general solution here, plug in t equals 0. But before we do that, actually, let's first use Euler's identity and rewrite this. So e to the a plus bi is just e to the a times cosine b plus I times e to the a sine b. So e to negative 5 over 2 plus 6i t, well, a is going to be negative 5 over 2t because you want to distribute the t to both terms. And so the b is going to be 6it, or rather 6t, because we don't include I for b. So it should be 6t, and that goes inside the parentheses. And we do the same thing with negative 5 over 2 minus 6i. Okay, now we add these two together, and notice that cosine of negative 6t is just cosine of 6t, and sine of negative 6t is negative sine of 6t. So we can combine these two together. We have e to negative 5 over 2t cosine 6t, and then this is a positive. It's the same thing. And we have a c1 plus c2 in front of it. That gives us this one. And then we have this negative turns into positive, and this comes outside. So we have these two are the same, but the coefficients again are c1 and c2, but there's a minus that separates them. So that's why we have c1 minus c2. And then of course the I and E and the sign. So now c1 plus c2, we could just call that some other constant, c1, and then I is also a constant, and then c1 minus c2 is another constant, so I'm going to call it c2. Okay, so this is my solution, my general solution. So now I can take the derivative of this thing. So we'll have to use product rule. So first we'll work with x of 0. So if t is 0, that means cosine of 0 is 1. So this is 1. This is 1. And sine of 0 is 0. So this whole thing becomes 0. So we're left with c1 equals 4. Now for the derivative, we're going to plug in t equals 0. So we know sine of 0 is 0. So this is 0. This is 0. Now cosine is 1, and then e to the negative 5 over 2 times 0 is 1 as well. So I'm left with negative 5 over 2 c1 plus 6 c2 equals 16. So because c1 was 4, plug that in for c1. Solve for c2 to get 13 over 3. So now we put it all together. This was our general solution. This was what our constants were. So our final answer is 4 times e to negative 5 over 2t times cosine of 6t plus 13 over 3 times e to negative 5 over 2t times 6t.